Hi, everybody, and welcome to Numbers with Nora. This is a math tutoring channel that helps you with all your math tutoring needs, questions, homework questions, and yeah, just all kind of math help. So this video is going to be in regard to the SAT math prep. I'm going to be using Kaplan SAT Math Prep 8th edition. I'll sit there and put a link to that book down below as well. I think this is a really good book if you're trying to study and prepare to take your SAT. They have a really good breakdown of each chapter and what math is going to be on the SAT, and as well as 2 practice tests in the back of the book. All right. So we're going to start with chapter 1, which is the method of SAT math questions. And that's what this section or this quick video will be on. So let's begin. So again, the objective of this video is to help you answer SAT questions, whether you are comfortable with math content, or if you're not that comfortable with math and you need more other tricks and other things to see to help you guide you along the way, right? So that's what we're going to look at really quick as our tricks and tips for the math SAT section. So these are always good steps to take when you're taking the SAT, is to state your question and always box exactly what they're asking you. Use all the information and examine the information that they're giving you as well. And always choose your approach, okay? So if you're not sure how to approach the problem, you can sit there and try to back solve with the answers they give you. Try to pick and play around with easy numbers that might have like some source of letting you see what your options are. You can do traditional math, which for each SAT question that I solve, I will show you the traditional math way and what standard I'm using. And then also I'll sit there and show you tricks if you don't understand that standard as well. You can always guess or estimate, make your best guess, or you can take a strategic guess, right? And then confirming that you answered the right question. And that's what I'll sit there and show you as well. The more SAT practice problems I sit there and put on this channel is just how to check your answer correctly with math. Okay. All right. So the best way to practice SAT is just jumping right in there and getting into problems. So for these 3 problems that I'm going to do on this video, I'm going to show you the mathematical way to prove it. And then I'll show you a trick that you can do, like I said, if you're not that comfortable with math content quite yet. Okay, so let's look at this first one. This one says the state fair sells food coupons for $2 each and ride coupons for $3 each. If Marlon wants to buy at least 15 coupons and spend no more than $40, what is the largest number of ride coupons he can buy? So again, like I said, when you're taking your SAT, I always love to annotate my word problems. I like to see what they're asking me, underline important information, so I just don't get lost and forget. Okay, so the main question that they're asking us is, what is the largest number of ride coupons he can buy? Okay, they also set us up with 2 variables, food coupons, and they give us their $2 each. That's important. Ride coupons for $3 each. That's important. They tell me that he has to have at least 15 coupons and he can spend no more than $40. Okay. Now that I sat there and annotated and have all the information that they gave me for this word problem, I'm going to sit there and tackle it. Like I said before, I'm going to tackle it the mathematical way. And then after that, I'll show you some tricks if you don't understand this math method that I'm getting ready to use. Okay. But I will have more videos on this method I'm getting ready to use. So just off the bat, I see that they're giving me 2 variables. I'm going to have to deal with the quantity, and I'm going to have to deal with a spending amount. So I would sit there and use my mathematical knowledge and say that this problem is going to be a systems of equations that I have to set up and solve. Okay. So we are going to use system of equations. Solve this problem. All right, so with systems of equations, they sit there and give you 2 variables that you have to set up. So our 2 variables in this case is going to be food coupons and ride coupons. So let's let X equal the food. And you can pick any variable if you want to pick F or whatever. I just picked X and Y. Let Y equal the rides. All right. And with those two variables, I want to set up two equations. One of my equations is going to have to deal with the money, and my other one is going to have to deal with the quantity. That's how I like to think of setting up system of equations, right? So like I said, one is going to have to deal with the money. So our money one right here says 2 each and 3 each for rides, right? So my food is X. So every time I sit there and get food, it's going to cost me $2. So that indicates multiplication, 2X. And then my rides are 3. So each ride I take is going to be $3. So that's 3Y. And that's going to equate out to $40. Okay, that's how I can sit there and calculate the money portion. Now, the quantity portion is always the easy equation. It's just adding, like, just taking your variables. So X plus Y. And that's going to be equal to, he said 15 coupons is at least how many he wants. Okay. That's how I set that up. Okay. And the next thing we're going to do, probably it's not going to be perfect, guys. Sorry. I'll make it look better when I write it up there. So now that we set up our two equations and stuff like that, of course, next we want to sit there and solve. Okay. So to sit there and solve these two equations, we're going to use the process of elimination. Now, again, I'm doing this mathematically. So if you don't remember your systems of equations, don't worry. I'm going to sit there and go over that whole chapter and we'll learn them together. Okay. So for my systems of equations, I can sit there and type this one out. Let's put it up here. I'll put we're using elimination for these two. Actually, let me write it up here. It's neater if I write it up here. Okay. No, I'll draw out the rest. So for elimination, our goal is to sit there and eliminate either our X or our Y variable by manipulating either our first or our second equation. For this one, that's where I go back up here, and they're asking us for our ride coupons. How many ride coupons? So our ride coupons are our Y. I don't want to eliminate my Y because my answer, they want to know how many Y. So I'm going to try to eliminate my X, the food, okay? So I'm going to manipulate the second equation by multiplying all of these by -2. Right? And that will allow me to sit there and eliminate out that X. And we'll see that in just a second. So that's -2. Right? So when I sit there and distribute that -2, and it has to hit each and every one of my variables. Right? Let me rewrite this down here. And then distribute that through. This is my first equation. So we don't do anything to our first equation. We just leave it alone. Okay. Now my second equation is where we're the one we're manipulating. So I distribute that -2 through. I get -2x minus 2y equals -30. Right? After I manipulate that, now I simply just add my two equations down like this. I'm always adding them, okay? So now I get what I want. 2x plus -2x, that just cancels out, which is golden, good. I just want one of my variables. Now I have 3y minus 2y. That's just going to give me y. 40 minus 30, that gives me 10. So what we just found right now is that with 15 or with $40 and 15 tickets, he can go on at least like 10 rides. Okay. So our answer would be B. Now, if you didn't know how to approach the problem using system of equations and elimination, you didn't know how to do that, then there's another way you could have approached it and looked at it kind of like more thinking wise. Okay. The more thinking wise way I would say is, okay, if you sit there and you have multiple choice. So let's say you want to sit there and look at your multiple choice and you're like, okay, so I know he has to take 15 rides. All right. My answers are giving me the number are 15 rides and food. So I know my answers are giving me the number of rides, but I want to look for the number of food that I would get. So let's say if we plugged in chug, I call it plugging and chugging, when we use our answers to plug into our paragraph. So I know if he has 9 rides, he's going to have 6 coupons for food because he wants at least 15 coupons, right? So 9 plus 6, 9, 10, 11, 12, 13, 14, 15. All right. So if you do 9 times 3, right? Because those are my rides, plus 6 times my food coupons are 2 each. This would equate to $39. It's close to $40, but if we sit there and you would do this for each A, B, C, and D, which takes a little bit longer plugging and chugging. That's why it's always better to know the math. But if you sit there and do the same strategy for B, you will get that the answer is 10 because 10 will hit you on $40. All right, cool. So let's go on to the next one. Let me just push this up a bit. What's not in our way? Boop. All right, so let's look at this one. And by the way, if you want to sit there and follow along in the Kaplan book, I'm picking out the problems that are labeled difficulty-wise as hard, because I know the SAT, you want to sit there and practice with the harder problems and, get the best practice you can. So for this one, which of the following is equivalent to the expression above for x more than 1/3? So again, I'm going to show you the mathematical way to sit there and solve this. After that, I'll show you a trick that you can use if you're not sure of the way to solve this. So for this one, the section that this is going to be called is dealing with rational expressions. So right now we're adding rational expressions, okay? So to do this, let me rewrite it right here, show you all the work. So the first thing I notice is I can sit there and rewrite that +4 as a fraction, because when I'm dealing with a fraction and then a whole number like that, I like to write it as a fraction. And a way I can write a whole number as a fraction is by putting it over 1. Okay. So this is kind of like adding fractions now, right? Where my fractions have to have the common denominator in order to add my numerators. So what I can do is actually multiply my denominators together. 3x minus 1 times 1, that's just 3x. Minus 1, because anything times 1 is itself, right? And this is just like we're adding fractions. All right. So now I'll be able to have the same denominator. But then when I multiply this side by 1, I have to multiply whatever I do to the bottom, I have to do to the top. So now I multiply this one because I multiplied this side by 1. Then I multiplied my numerator over here by 3x minus 1. So I have to do the same for over here. I have to multiply this by 3x minus 1. I'm going to run out of room. Sorry. So I might erase that. Minus 1. Right. So for this one, it would be 4. 3x minus 1. And then for this one, it's just 1 times 2, right? Because what I do to the top, I have to do to the bottom. So I put times 2. All right. If you're confused how I set up that fraction, I'll sit there and make a video as well as adding and subtracting fractions, because that's just basic adding, subtraction, adding and subtracting fraction knowledge. It's not going to let me get rid of that. That's fine. All right, so now I have this portion. I have 2 over 3x minus 1 plus 4 in parentheses, 3x minus 1 in parentheses over 3x minus 1. Now both my denominators are the same, so I can sit there and rewrite this by adding my numerators. And again, I can go ahead and distribute this through. Okay, I'm just using algebra. So 3 times 4 is going to be 12. Okay, 12x. And then minus 4. And this is all over, I can write it all over the same denominator now, 3x. Minus 1. Now I want to sit there and get my like terms together, okay? The only 12x I can't combine with anything because I see that x right there, but this 2 and 4 and negative 4 are constants. I can combine those together. So 2 minus 4, that's going to give me minus 2, so 12x. Minus 2 over 3x minus 1. All right. Perfect. And that's the most I can really go down and simplifying. I could sit there and pull out a 2 and factor out a 2, but there's no reason to do that because I can't cross out anything with my denominator. So my answer would simply be C. Okay, that's the mathematical way to go so. And that section is adding and subtracting rational expressions, right? So now if you didn't know how to add and subtract rational expressions, or you blanked out and forgot, then there's also another way to do this as well. And again, we're going to use the plug and chug method. That's what I call it when you're sitting there taking numbers and just plugging them in and trying to get an answer out without doing the math behind it. So for this one, I notice I do have a rational expression up here, and they said which one is equivalent to it. So why not pick out an easy number to plug in here, see what my outcome is, and see what outcomes would be for the rest of them. So let's choose a number. Let's let x equal 1. Okay. So if I sit there and let x equal 1, what I can sit there and do is everywhere I see an x, I put a 1. Minus 1. And then plus 4. Now I just use basic algebra to sit there and simplify this down. I get 2 over 3 minus 1 is 2 plus 4. Now I get 1 plus 4. This is going to give me the answer of 5. So now I know that this expression, when my x is equal to 1, this expression has to equal 5. So what I would do is I would go back and I would plug in 1 to each of my options, and whichever option gives me the answer 5 will be the correct answer. And in this case, we said it's C. If I plug in 1 to all here, 12 minus 2 is 10. 3 minus 1, that's 2. 10 divided by 2 equals 5. So we would be able to see that C would be the answer after we plug in 1 to all of my options. Okay, so that's a trick to go around if you didn't know how to add or subtract rational expressions. Okay, let's do the last one really quick. Down. All right, so this one again, like I'm picking the most hardest problems from the section. If there's any other problems if you have the same book or any other SAT problems you want me to work out, just put in the comments and I'll work them out for you and show you all the work behind them. All right, so let's look at this one. For this one, we're dealing with graphing. You're going to see a lot of graphing on the SAT sometimes, especially with parabolas. All right, so the graph of the function f in the xy plane above is a parabola. Which of the following defines f? Okay, f is our function. Notice some things before you start trying to circle stuff and go crazy and try to figure it out, let's notice some things. Let's notice the vertex of this parabola. I notice the vertex if I go over 1, 2, right? That's my x. And if I go down 1, 2, 3, -3. So 2, -3 is my vertex of this parabola. I notice my parabola is opening down, which means my a coefficient is going to have to be negative, or there's a negative in front of my x squared. Okay. So those are some things I know right off the bat. I know if we have to have a y or x, or if we have to have a y-intercept or an x-intercept, we have it, because when my x is 0, I have a y. My apologies, I was mixing those up for a second. And then let's go for it. So it says, which of the functions? So for this one, for knowing our parabolas, it's very important to know the parent function of a parabola. The parent function of parabola is y equals a, in parentheses, x minus h squared plus k. There's also another parent function way to write this out, but for right now, this one's going to help us. This one's going to help us the most on this problem. All right. So like I said, we're looking for a parabola that opens down, so my x squared coefficient has to be negative. This one's negative, cool. This one, I believe if I factored that out, it would be negative. This one, I don't believe would be negative, and this one is not negative. So C and D I can cross out right away. Another thing I noticed, I need to have a vertex of 2, -3. If you recall, H is my X of my vertex and K is my Y of my vertex. Okay, H, K. So just by looking at that, I would know that this would be, remember you also do the see that negative is part of my formula. So I know this would be -2, which checks off because -2 is, no, +2. This would be -2, -3. Okay, because we always do the opposite of what's inside my parentheses. So that's not -2, that's +2. So we know B would not make the cut. So we can assume that C or A would be our answer. And if we wanted to know that A is our answer, you can sit there and factor this out and put it in this form. Okay, but factoring this out, I think we couldn't use the cross method. We would probably have to use a quadratic formula. But I think for this one, it's best to just use your process of elimination. And the key was knowing this form, or this parent function right here of a parabola. All right. So that's all the time that we have in this section for doing those 3. Again, if you have any homework questions or would like further tutoring in regards to any kind of math subject, please subscribe or leave a message in the comments section for any kind of math questions or homework questions that you need answered, and I can help you out. Thank you, guys.